Before the era of printers and instant photocopies, there was a time when copying even a single page was a slow, messy, frustrating task. In the early 1930s, offices were filled with typewriters, carbon paper, and tired clerks bending over documents for hours. In one such office, surrounded by towers of files and endless paperwork, sat a young patent clerk named Chester Carlson. Chester wasn't powerful. He wasn't wealthy. He was simply a quiet man doing an exhausting job. But unlike everyone around him, Chester kept asking himself one question: why is copying still so hard? Every day, he handled hundreds of pages that needed duplicates. Sometimes 3 copies, sometimes 5, sometimes more. Each one had to be typed again or copied by hand, and every mistake meant starting over from scratch. Ink smudged, carbon paper tore, machines broke down. The whole process was wasteful, slow, and painfully inefficient. But while the rest of the office simply accepted this as part of the job, Chester didn't. He looked at those piles of paper and thought, there must be a better, simpler, faster way. Most people see a problem and walk away. Inventors see the same problem and lean closer. Chester wasn't trying to change the world. He was only trying to make copying easier for himself, for his coworkers, for everyone buried under paperwork. But that simple frustration became the spark for a global revolution. Every evening after the office went silent, Chester walked home replaying his day. He thought about the waste of time. He thought about the struggle. And slowly, a wild idea began to grow in his mind. What if copying didn't need ink? What if it didn't need chemicals? What if it could happen dry, a copy made with light, electricity, and powder? It sounded impossible, but Chester couldn't ignore the thought. He turned his kitchen into a small laboratory. Instead of pots and pans, there were metal plates, chemicals, and bits of powder. While the city slept, he experimented. He remembered the concept of photoconductivity, how certain materials change their electrical charge when exposed to light. And he thought, if light can carry the image and electricity can hold it, maybe powder can reveal it. Slowly, piece by piece, theory became experiment. Experiment became hope. Hope became purpose. Chester Carlson didn't begin with genius. He began with annoyance. And that annoyance led to curiosity. Curiosity became passion. Passion became invention. This, right here, is the true beginning of electrophotography. Not a sudden flash of brilliance, but a lonely young clerk refusing to accept the world as it was. Before Chester Carlson became the father of modern photocopying, he was simply a quiet boy growing up in a world far from comfort. His story doesn't begin with success. It begins with struggle. Chester was born in 1906, in a family that never had much but always seemed to lose more. His mother was frail, fighting tuberculosis. His father suffered from painful arthritis that made even simple work difficult. And so, from a young age, the weight of the household slowly shifted onto Chester's small shoulders. He cooked meals. He cleaned the house. He held part-time jobs while keeping up with school. Most children his age played outside. Chester lived a life of responsibility, doing whatever he could to keep his family going. Yet in the middle of hardship, something remarkable took root inside him: curiosity. While other boys collected toys, Chester collected broken wires, discarded batteries, and scraps of metal from junkyards. He didn't see junk. He saw pieces of puzzles waiting to be solved. Science fascinated him. Electricity intrigued him. He tinkered, experimented, and dreamed quietly of understanding how the world worked. It wasn't ambition that drove him. It was escape. Science was the one place where problems had solutions. And despite poverty pressing in from every direction, Chester held on to one hope: that education could change his life. That hope led him to one of the most demanding scientific institutions in the world, Caltech. He arrived with barely enough money for books, but he had determination, and that was enough. At Caltech, Chester worked constantly. Days in class, nights at part-time jobs, cleaning labs, sorting books, anything to stay enrolled. He lived frugally, studied relentlessly, and pushed through every challenge with the quiet endurance he had learned in childhood. He graduated not because life was easy, but because he refused to quit. After Caltech, Chester found work as a patent clerk. It wasn't glamorous, but it surrounded him with ideas, inventions, diagrams, mechanical theories. Each day he read through pages of innovation, and each day he was reminded of what he truly wanted, to create something of his own. It was during these years that he married Elsie May, a gentle, understanding presence in his life. Their home was small, too small, really, for what Chester turned it into. Because soon, their kitchen became a laboratory. There were metal plates on the counter, powders stored next to the spices, and electrical wires running across the table where dinner used to be served. Experiments failed more often than they succeeded, but Chester kept working, adjusting, learning, always learning. Elsie watched him quietly. She saw his disappointment, his moments of doubt, and the spark that never left his eyes. Looking back at Chester Carlson's life, you don't see a man groomed for greatness. You see a survivor, a fighter, a boy strengthened by hardship, a student shaped by struggle, a husband powered by hope. Every difficulty he faced taught him something he would need later: patience, persistence, the courage to keep going when the world said no. These weren't lessons from books. They were lessons from life, and they forged the inventor he would become. There are moments in history when a simple idea, born from frustration and persistence, ends up changing the world. For Chester Carlson, that moment arrived in a small rented room in Queens, New York, a room so tiny that the kitchen sink doubled as his laboratory, and the walls smelled of chemicals more than food. But Chester wasn't discouraged. He had a belief, a fierce, unshakable belief, that copying a page shouldn't require hours of exhaustion or an entire room full of machines. There has to be a better way, he kept telling himself. And that belief became his compass. Every evening after work, when most people rested their tired backs, Chester would come home, loosen his tie, and turn into a scientist, an explorer of the unseen world of electrons. His wife, Elsa, watched him with a mix of worry and admiration. He often returned from the lab with ink-stained fingers and red eyes, but he carried a spark, the spark of someone who knew he was standing at the edge of discovery. Chester had always been fascinated by how materials responded to light. The idea had first come to him in the library, years earlier, while he was flipping through a book on photoconductors, materials that change their electrical properties when exposed to light. What if light could carry an image? What if electricity could hold it? And what if powder could reveal it? These questions followed him like loyal companions. So, in 1938, on a chilly October afternoon, Chester gathered the few materials he had: a sulfur-coated metal plate, a small ultraviolet lamp, a mixture of powders, and a sheet of wax paper. He prepared the plate carefully, rubbing it until it was clean, then charging it with static electricity. The room was silent except for the faint buzz of the lamp. Then came the moment. He placed a small glass slide with the handwritten words 10-22-38 Astoria over the plate and exposed it to light. The parts touched by light lost their electrical charge, the dark parts kept it. Chester sprinkled fine black powder across the surface. The powder danced, moved, and settled exactly where the letters had been. He held his breath. There, right in front of him, the very first electrophotographic image appeared, faint, imperfect, but undeniable. His assistant, Otto Korne, watched in astonishment. "It worked," Otto whispered. Chester's hands trembled. This will change everything," he murmured. But invention alone wasn't enough. Chester approached more than 20 companies, including giants like IBM, and each one told him the same thing. No, too slow. Not practical. Maybe try something else. Any other person might have quit, but Chester had lived his whole life pushing through hardship. This was just another mountain. Eventually, a small, struggling nonprofit called Battelle Memorial Institute took interest. They didn't fully understand Chester's idea, but they believed in the man behind it. Battelle helped refine the process, and later, A tiny paper company named Haloid licensed the invention. Haloid would eventually rename themselves. The world didn't know it yet, but a revolution had begun. A revolution born in a cramped kitchen, fueled by determination, and held together by the hope of one man who refused to give up. And so, Chester Carlson stepped from the shadows of failure into the dawn of innovation, carrying with him the promise of a technology that would change offices, businesses, and communication forever. This was not just an invention. This was the beginning of a new way to multiply knowledge. Before the world knew the word Xerox, before offices buzzed with copy machines, there was a simple but profound question. How do you trap light and turn it into ink? To understand Chester Carlson's genius, we must step inside the invisible world of electrons, a world where light reshapes electricity, where dust behaves like metal filings following a magnetic field, and where a simple sheet of paper becomes the stage for a tiny miracle. Let's imagine the process step by step, not in a cold laboratory tone, but as if we're watching a story unfold. Picture a smooth rotating drum, coated with a special photoconductive material. In Chester's early experiments, this was sulfur. Later, it became selenium, and eventually organic photoconductors in modern machines. In darkness, this material holds electric charge very well, almost like a balloon rubbed against your hair. A tiny wire called the corona wire sprays the drum with a cloud of negative ions. The drum becomes evenly charged, a blank, invisible canvas waiting for an image now. Imagine a bright light scanning across the paper you want to copy. Where the paper is white, the light reflects strongly. Where the text or picture exists, the light doesn't bounce back. The reflected light hits the charged drum, and here is the magic. The parts of the drum touched by light lose their charge. The dark areas, where the text on your paper block the light, keep their charge. Suddenly, the drum is no longer blank. It holds a perfect electrical outline of your original page. Not ink, not toner, but an electrostatic shadow. This was Chester's great insight. Light could write an image using electricity. Now the drum moves past a reservoir of very fine black powder called toner. Toner is not ordinary dust. Each particle is engineered to carry an opposite electric charge from the drum. Opposites attract. So the toner jumps onto the charged areas of the drum, the areas representing the dark parts of the image. Letters, borders, shapes. The uncharged areas stay clean and untouched. In this short moment, the electrical shadow becomes visible, a living, breathing image made of tiny black particles. A clean sheet of paper slides beneath the drum. The machine charges the paper with yet another electrical charge, this one stronger than the drum's charge. The toner releases from the drum and leaps onto the paper as if pulled by an invisible magnet. And now the paper holds the image. But it's still delicate, still loose, a whisper of an image waiting to be fixed. The final moment belongs to heat. The paper passes through hot rollers, the fusor, which melts the toner particles and presses them firmly into the fibers of the paper. With a soft hum and a warm sheet sliding out, the copy is born. Clean, sharp, permanent. All created through a dance of static electricity, light, and powder. What Chester Carlson invented was not just a machine. He invented a process, a sequence of events so elegant, so reliable, that even decades later, the core principles remain unchanged. Every photocopier today, every laser printer, every office where pages fly and ideas circulate, all of them still follow the same cycle Chester perfected in that tiny kitchen back in 1938. Charge right arrow expose, develop right arrow transfer, right arrow fuse. 5 steps, 1 vision, a lifetime of persistence. And that is the true brilliance of Chester Carlson's invention, a technology built on invisible forces that made human knowledge visible to the world.